Hello and welcome, ladies and gentlemen, to this simple presentation about robotics. This will be a series of two presentations today and tomorrow. Today I'll be discussing a brief introduction to robotics and their history. And for next time, I will be discussing Python and other sort of things like object-oriented programming and that sort of thing. So in total, there will be about 4 or 5 like live streams and if you guys attend all of them, please attend them to the end so that you can answer these forms. And once you answer the form, you can get yourself a certificate. Anyways, my name is Mohammed Almutoory. I am a second-year student at Memorial University. And as for how I got into robotics, my father, he brought a robot home for one of his projects. And I looked at it and I was very interested in technology at the time. I was like, can I work with you? And he was like, sure. And ever since then, I've been working on several of these projects with him. One of the most notable ones being a program that teaches children how to pray. This the simple etiquette of praying and teaching them about COVID, right? What they should do, and a small song and a dance about COVID, and teaching them about, teaching special needs children stuff like the alphabet, multiplication, mathematics, that sort of thing. And yeah, that should be it as far as I'm concerned. If you guys have any questions, please let me know before I start. I don't see any questions, so I guess I'll just get right into it. Okay. Before we discuss robotics, we have to first discuss AI. AI is artificial intelligence. Okay, yes. AI is artificial intelligence, right? It is a field of study whose primary concern is finding an effective way to understand and apply intelligent problem-solving, planning, and computation skills to a wide range of practical problems. So, in simple layman terms, AI is basically like trying to emulate human reasoning and human thinking in a program. What would a human do in that specific situation? Right? That's what the computer is trying to copy or emulate. Of course, there's different sections in AI, one of which is speech and vision recognition. Right? We know that, for example, in Google Assistant, we have speech recognition. Right? You can talk to the phone and you can ask it certain questions, and it will respond accordingly. We also have, vision recognition for cameras. Right? We use it for facial recognition in our phones, in our iPhone, for example. They removed Touch ID, so they replaced it with Face ID, which uses your face as an authentication process. Also, we have other different types of AI. We have soft computing. Soft computing is basically the polar opposite of hard computing. And hard computing is trying to solve a problem the most efficient way possible, no matter the cost. However, soft computing is a bit more relaxed in the sense that it's a bit more balanced. It balances cost and efficiency for something that's a bit more reasonable. One example of this is the traveling salesman problem. Some of you might have heard of it before. The traveling salesman problem, you have a bunch of different points and you're trying to find the most efficient path to go through all of them. This is something that has been plaguing AI scientists for years, and they're trying to find the most efficient way possible to solve it. We also have NLP, which is natural language processing. Natural language processing, it ties in well with speech recognition, right? It helps us to recognize like language, like English, for example, so we can talk to the robot and it can talk back to us. It's also used in, for example, Google Assistant. We also have, planning, and we have expert systems. Expert systems, these are useful for what do you call it? For helping experts in a field. So we get a bunch of experts in a field, let's say the medical field, a bunch of doctors, and we ask them for their data, questions, and trying to gain their expertise. We save that in a database, and we can train an AI model on that database so that it can help us diagnose patients. A computer can diagnose patients. This is especially useful as a second opinion for a doctor, so he can be more confident with his diagnosis. And the final one is robots. This is the one that we'll be discussing today. What is robotics? Robotics is basically like a branch of AI, but it is more concerned with the hardware side of things. So, for example, it includes electrical engineering and mechanical engineering, and how these things, like how the hardware interacts with the software, which is the computer science aspect of designing and construction of robots. So, the hardware side, it includes stuff like actuators, sensors, and that sort of thing. This feeds in like data to the software, and the software will it will process it, and then it will give directions to the hardware so it can make changes in the world. As you can see here, there's three examples of robots. There is Aibo, Asimo, and Nexi. And these are all built in different times, and they have wildly different shapes. Robots, they're not limited to humanoid robots. You can have a dog, for example. Okay, what is an intelligent agent? An intelligent agent is anything that can be viewed as perceiving its environment through senses and acting upon that environment through actuators. So let me give you a good example of this. I'm sure everyone has heard of Tesla by now. They make these like smart cars, and they're electric only. And it's a good example of an intelligent agent because in this case here, the agent is a computer inside the Tesla car. This car is constantly collecting data through these sensors about the surrounding, right? It's constantly getting data about from the surroundings, and it perceives it from the environment. The environment is constantly giving out data that is collected by these sensors. This data is then taken to the computer, and then it will it will be processed by the computer for useful data. And according to that data, it will send signals to the actuators, which in this case is, like, let's say the brakes, or let's say the vehicle handling, or that sort of thing. And these actions are going to cause changes in the environment. Okay, let's move forward. Well, actually, if you think about it, when you think of intelligent agent, wouldn't you really think that that's sort of like a robot? Exactly. You see here. What is a robot? A robot is an intelligent agent that interacts with the physical environment through sensors and effectors. Let me give you another example of something that interacts with the physical environment. We have, let's say, a greenhouse. What is a greenhouse? A greenhouse is a building in which you can plant vegetation, right? But the special thing about it is you can control all of the variables that are, involved in the and like helping the vegetation grow. For example, things like moisture, things like temperature, things like humidity. All of these things can be controlled. So in this example, will be using a sort of like an Arduino. An Arduino is like a small chip, computer chip, and it will, what do you call it? Yes, it will be taking data from the surroundings using a bunch of, sensors. And these sensors can be temperature sensors, they can be humidity sensors, and that sort of thing. They're always collecting data about this specific environment. And this data obviously is going to be processed by the Arduino, and it will constantly be checking the temperature and the humidity, right? Eventually, for example, there's a sunny day, and in that day, the water is drying up. The water level drops really low, and this is very harmful for the plants. Obviously, they can't grow anymore. So the Arduino will detect that, and it will send a signal to a valve. A valve is a sort of like a switch, but for a pipe. And once it sends that, it will open the pipe, and water will start flowing into the greenhouse, and the plants can start growing again. It will constantly monitor these things and make sure they are stable. In this case, the external world, let's look at this diagram here. The external world is the greenhouse, and the sensors are the temperature sensor, the humidity sensor, and there is perception. Perception is basically these sensors. They collect data about the surroundings, and they form like a sort of model of what is happening in the current environment. And this model can be used to process behaviors and action selection, planning, learning, and that sort of thing. This is useful to help us make decisions or actions, in this case, for example, obstacle avoidance in the robots, for example, when they're walking around, they want to avoid it. But in the case of the greenhouse, right, the action is trying to increase the temperature or increase the humidity and that sort of thing, right? So this will send an action to the actuator, which in this case was the valve, and it will open a water supply that will increase the water, and that will cause changes to the external environment. As you can see here, it is a self-fulfilling prophecy. It's a loop. It keeps on going forever and ever. Okay, let's move forward. Fundamental elements of a humanoid robot simulator. Here, as you can see, we don't always have access to these robots, right? For example, myself, currently, I do not have access to the robot I will be demoing soon. So I will instead be using a virtual robot and a virtual environment. Basically, what these do is they simulate what that specific robot would do in a specific environment. As you can see here, in the main piece, which is the environmental interaction, there's two models, the humanoid model and the environmental model. You can see there's two arrows between them, right? They will constantly be affecting each other. And there on the left side, you can see, oh wait, I have a question. Sorry, let me check. Actually, not all robots need to have AIs in them, but they could, Some robots are made for a specific task. For example, like let's say in the, in the industries, for example, we have these robots that do one specific task and only one task, which is just placing pieces of metal or riveting them or making holes in them. They don't need to always have an AI, but the ones we will be discussing are a bit more smart, I guess, and they don't. Oh, and they will probably have some sort of AI in them. Okay, back to the lecture. Yes, as you can see on the left side, there will be a user-specific controller. This is the thing that we will be using to interact with this robot. This is what we will be using it to tell instructions to the robot, and that sort of thing. So we send a command signal, as you can see on the diagram, to the human model. Then it will cause it to make changes. Right? It will start moving around. It will move its arms, and sometimes it can cause changes to the environment, as you can see here, the environmental interaction. And to see these things, right, we need to model a GUI, a graphical user interface, so that we can see what on earth is happening between these two models. And so you can see here, there's these two arrows, and they send their data to a GUI-based output, so we can see what is happening in the model. Anyways, the humanoid model also sends data back to the user-specific controller, so that we can have an updated view of what the robot has done so far. So we can make decisions accordingly of what to do next. Okay. Here is just a small recap of what I've talked about so far. There is perception. Sensors give information about the environment or the robot itself. There is processing. This information is then processed to calculate the appropriate signals, and there is action. Signals are then received by actuators, which move the mechanical pieces of the robot. History of robots. As you can see here, right, robots, they're not a particularly new phenomenon. They have been a thing for quite a while now at this point. As you can see, as early as 1932, robot Lilliput, that's one of the first robots. And as you can also see, Japan, they have quite a long history with robotics. As you can see, there's quite a lot of examples. There is Waybot 1, there is Titan 3, there is Kiribo. There's all of these different robots that you can do more research about if you like. But I won't really be discussing them very much today. Here, there's also more examples of robots, also from Japan. And as I said earlier, they don't have to be humanoid robots. They can be a dog. And this one is Aibo, and it's created by Sony. Okay, now let's discuss the applications of robots. Robots, they have a lot of wide use cases, and they can be used in many different places, right? So one of the first applications of robots is in the industrial side. They can be used to handling material, cutting, welding, assembling, drilling, polishing. These things, for example, in the car industry or the plane industry, or in all of these industries, in the what do you call them, the factories, they started using robots. You can't really keep using humans because they're not as efficient and not as cost effective and not as fast. Robots, they don't need any breaks, they can keep on going forever, and yeah, it's much more efficient overall. And this has helped us get a wide variety of items that we can just buy whenever we feel like. And it increased the overall, like we can get what we want. We don't have to worry about things, and there's always things in supply, in demand. I mean, in supply and available. They're always available. Now let's discuss exploration. Exploration, right? About many years ago, they sent someone to the moon. They sent them to the moon, and they walked around and gathered information, and it was great, right? It's a huge accomplishment in human history, but it's very dangerous. Sending a human out there and says, you can risk. They are risking their lives so they can get information for humanity's future, and obviously we don't want that, right? Because there are some cases, unfortunately, where the spaceships, for example, they explode and people on them unfortunately die. So people are building robots these days to, replace the humans, so that just in case anything goes wrong, we don't really care what happens to the robot. We can just build a new one. But then human lives, they're very important. Other things, for example, it's not just space. They can also be used in exploration in extreme environments. For example, going underground or going underwater really deeply. When you go down in the water, the pressure gets really high, and putting a person down there, they can suffocate, and it will be really difficult for them. So instead, we send a robot that's, again, replaceable. And if anything goes wrong, we just build a new one and send it. And they can be equipped with a variety of different things like sensors and actuators that can help them maneuver the environment and can help them gather data about that environment that's valuable to us, so we can make predictions or make ideas of what is happening down there. Anyways, there's other uses like military. We don't really like discussing these because it's a bit grim, war and that sort of thing, but they can be used for it. You can have a drone, for example. It has a bunch of different sensors, right? And these they can help scour the area, looking for let's say planes from different countries that are trying to spy or that sort of thing. They can also robots for fighting. They can be equipped with weapons and that sort of thing. There is also medicinal aspects to robots or applications to the robots. Recently, they came up with this robot that can help with very precise and accurate surgery. For example, some doctors, they are brilliant. They know exactly what they need to do, but they have shaky hands. They can't really work on a patient. They can't risk that because the body is very delicate. So they came up with this robot. This robot can make really small movements, and to make sure that the patient does not get injured, even in the micrometer type of range. It's very accurate. Also, we have for the entertainment industry. In the entertainment industry, for example, you can make a robot sing, you can make it dance, and you can record it for YouTube or TikTok or something. Make your friends laugh. It can also be used in films, and they can be used as props. They can be used as that sort of thing, right? And finally, robots can be used for services. There is security guard, there's delivery, and there's cleaning. The ones I want to highlight is delivery and cleaning. For example, Amazon, they came up with their drones that can help deliver packages instead of people, right? It's very efficient, it's very nice, but obviously it's not perfect. So they're constantly evolving and making them better. And the biggest use case besides industries is cleaning. These days they came up with these Roombas, these like automatic vacuum cleaner things, like these robots, and they can clean your entire house without you having to make any single interaction, and they can be gotten for as cheap as $200 these days. Technology is evolving. As you can see down here in this little graph, there is many different industries and how they relate to each other, but they all go back to the robot. Okay. There is 3 different types of robots. There's manipulators, there's mobile robots, and there's unmanned vehicles. But obviously, it doesn't have to be just these three. You can have a combination of robots. For example, the Now robot, the one that I worked on, it's called Now NAO, and it has both arms and it has legs, so it can fall into both categories of manipulators and mobile robots. Manipulator robots, most of the stuff, like as you can see here, there is the industrial side. There's mobile robots, they can be used for exploration and that sort of thing. And unmanned vehicles, they can be used for military applications. Here is a bunch of different accomplishments that have been done by robots over the years. As you can see on the right side, we have Now. Another question, let's see. Does Lockheed Martin have War Robot? Lockheed Martin. I have never really heard of this guy. I'm not sure what you're talking about. I'm sorry. But War Robots, they are a thing. They are a thing. That's for sure. And it's quite unfortunate, but that's how it is. Anyways, back to the slides. Yes. Here's the accomplishments. As you can see on the right side, there is Now. This is the one I have been working on for quite a while at this point. As you can see here, it's humanoid. It's cool. Anyways, on the left side, we have the industrial robot. That's one of the first things in the robot accomplishments. They started using robots in the industrial space for building things, for carrying heavy objects and that sort of thing. Then you can see NASA launches the first human-like robot into orbit. And like I said earlier, it's very dangerous to send people in space. Things can go wrong. So instead, we send a robot. And as you can see here, we have the self-driving car passes driver's license test. This is quite funny because there are so many people out there that still don't know how to drive. And now we have a robot that can do it for us. There's lots of people who argue that, self-driving cars are the future because they help reduce accidents and they're not really under the influence, and they can be on a network and they can all interact together to reduce accidents and that sort of thing. That's a whole other topic on its own, but I won't be diving into it for today. There's this here, robot specializing in handling household chores. This one here, like I talked about, a vacuum cleaner, for example, that Roomba. And as you can see here, efficient robotic tutors for smart generation. This is this is like the area I've been working in, helping children learn new things using the Now robot. And we have doctor performs first robot assisted surgery, like I said earlier with the surgery robots. Okay, now let's move forward. There is more examples of robots. There is manipulators. There is autonomous underwater vehicles, and like a submarine that's controlled by an AI. There is this thing here. I suppose it's a plane, and it's automatic as well. And there is this artificial soldier, and there is this rescue bot. This is very nice. For example, some people in war, they can be wounded in combat, and it would be quite dangerous to help them out, because you'll also be risking your life. So instead, we can have these rescue robots that can help out wounded soldiers on combat. And there's this one here, the Mars Exploration Rover. There is this rover that has been released, I think, by NASA or some other space agency. They released this rover called Curiosity. They sent it to Mars. It took about 6 months to arrive. If you send a human there, it's almost impossible to keep them alive. So instead, they made this drone thing, the Mars Exploration Rover. And they sent it to Mars to help collect valuable information about a world that we cannot reach. Because space is huge. There's so much stuff you can explore and find in it, but we just, we're really small. We can't really reach it very quickly, and we're very delicate. So we can send these robots instead, and we can collect valuable information. For example, they recently found that there was water on Mars, so there could be life. Who knows? Let's move forward. Humanoid robots. Humanoid robot. It's a robot with an overall appearance based on that of a human body. As you can see here, there is the different types of. There's this robot called Asimo, and these are the iterations that the designers they went through when they were designing this robot. At this time, you can see it's just a pair of legs, and they started evolving it more and more. As you can see, they put a computer in this box, and then slowly it became more advanced. Then they added arms, and eventually it became a humanoid. And all of this in the span of 20 years. It's pretty cool. There is also another different type of robot, Nexi, and what we currently have today, which is now. Robots, they can be used for the therapy of autistic children. Therapy of autistic children. And not just that, but that's an example, right? This is the one I've also been working on. You can see there is a wide variety of them. And one thing that stands out is they all look like toys. Autistic children, they're scared of interacting with people, They like to keep to themselves. So we designed these toy-like robots that make them more confident in interacting with it, And here's some examples. There is AI Soy, there is Keep On, there is Casper, there is Milo, there is Now. This is the one we will be programming soon. And there's Pepper. One thing about Pepper is they're made by the same company that makes Now, which is SoftBank Robotics. That's pretty cool. What are the top programming languages for robotics? So we have a wide variety of language we can use to program and make programs. And technically speaking, you could use any language you want, as long as the robot supports it. But the ones that are most supported these days are C and C++, Java, Lisp, MATLAB, Python, HDLs, BASIC and Pascal, and Microsoft C#. For the cases of for tomorrow's case, when I'm programming the robot, I will be using this GUI thing that has a bunch of modules and that interact together to program the robot. And each of these modules, they are programmed in Python. So if you're not satisfied with the modules that are built into the software, you can make your own modules and make it even more specific to what you need. That's the beauty of programming. You can make the robot do anything you want as long as you know the API. What are the top free simulation software libraries? You see, this is a very heated debate because there really isn't a specific software that is best for everybody. Each one has its own use case, depending on what you need. But the ones that most popular these days is Gazebo, because it's open source, and there is others like VREP and Weebot that are preferred for commercial simulators. Important criteria for choosing a simulator. The things to keep in mind when you choose a simulator is you want to make sure it's as close to reality as possible, because when you build your program, you want it to make sure that it's exactly the same as if you use it on a robot. You don't want it to build a software that will work in the virtual space, but then when you put it on your robot, it doesn't work and end up maybe doing harm to the robot. Maybe it does something that's an illegal move, or it moves too much, or it moves too fast. You have to keep these things in mind. These robots are expensive and a bit delicate at this point. They haven't matured to the point where they can be hyper movement. Still a bit immature. Anyways, other things to keep in mind. You want to make sure it's open source. When it's open source, you have access to the code. You can make modifications to the code. If you're not satisfied with something, you can make it yourself. And if you, for example, you're designing your own robot, and you want to add support for this robot so that other people can program it virtually, you can make your own library for the software if it's open source. It's much easier. Another thing to keep in mind is it has to be the same code for both real and simulated robot. You don't want to code a robot in the virtual space and that program just doesn't work on the robot. Like I said earlier, you want to make sure that it works. You want to save time. There's a reason you're working on the virtual robot. It's because you don't have access to the robot. So in the meantime, you use this one and program on it, and then you can use the programs later whenever you feel like it. Another thing to keep in mind, it has to be light and fast. These programs, they are very, very complex. There is so many things that are simulated. The robot, the actuators, how it moves, and how it interacts with the environment. All of these collision detection, all of this what do you call it, graphical rendering, and all of this. This takes a lot of stuff. It's a lot of computer resources to render and output. Another thing to keep in mind is customization. Like I said earlier, if you want to make your own robot or if you want to make modifications, it has to be customizable. And you need to be able to implement the environment that you have in the real world in this space, so you can as close to reality so you can like mimic reality as close as possible. So Gazebo, this is one example of like a virtual space. It's a multi-robot simulator for outdoor environments developed by the open source Robotics Foundation. Some advantages of this thing are it's easy and quick to set up, it's up to date, it has a nice graphical interface, so it's easy to set up, easy to use, and what do you call it? It also has good software stability, it doesn't always crash, and it has adequate adaptability with the robot operating system. Some disadvantages that are with this software are it's quite slow when you start making complex simulations. When you start adding so many objects to the space, it becomes very complex, and therefore it becomes quite slow, especially on slower computers. Another thing to keep in mind is it does not support all of the bullet features. This is like an open source physics library that is used to simulate, physics in the robotic space, and this might be a deal breaker for some people because the bullet supports features that may, for example, that we may need. Another thing to keep in mind is customization of large environments is time consuming. Maybe the tools are not that refined, so it takes time to do something that you'd be able to do in another software, for example, much more quickly. Here's more examples of other software. There is Bullet, which is an open source physics library mostly used for computer graphics and animation. There's also Vera, which is also another robot simulator that is developed by Copelia Robotics. And the special thing about this one is it supports multiple physics engines. There's ODE, Bullet, and Vortex. These physics engines, they simulate physics a little bit differently. They perform differently, like they try to be as accurate as possible, but they each have their own way of doing it. So it depends on your use case. For example, if you're trying to simulate a robot rolling or moving or jumping or stretching or that sort of thing, each of these, they simulate it differently. So it depends on your use case. For example, some things are better at, for example, jumping, or some things are better at rolling. So you have to make sure which one you need. Another one is Argos. Argos is a multi-robot, multi-engine simulator for swarm robotics. What is swarm robotics? Well, swarm robotics is a bunch of robots that are, they're all connected in a network, right? They interact, they're all controlled by one network, one singular object, and they all like work together for a certain task rather than just having one entity or one robot. And another one here is Weebots. It is a development environment used to model, program, and simulate mobile robots developed by Cyberbotics Ltd. Okay, this should be it for today. I discussed all of what it is for the introduction, and inshallah tomorrow we can be discussing the specifically robot now and how to program it. Yeah, that should be it for today. Thank you so much for coming. There should be links somewhere, and you can yeah, there should be links if you're interested, and if you want to make more, have more research, you can just read the links. And of course, make sure to keep in mind that you have to attend all 4 or 5 sessions till the very end, so you can get yourself a certificate. All right, that should be it. Thank you so much for listening, and have a good rest of your day.